Hello guys, just want to review the bonds before we move to the new type of bonds, which are covalent bonds. So all last week or the week and a half we did ionic bonds. And remember that ionic bonds are the ones that transfer. Also, you have a higher polarity. Remember that polarity means that they're unequal. So if you have something like sodium with 1 dot and chlorine with 7 dots, remember that this dot's actually going to transfer into that empty space. They transfer electrons. Okay, and that's what we did. So the new thing for covalent is going to have a lower polarity and they're going to share. Okay, so let's do an example of that. Okay, now remember that ionic bonds have a metal plus a nonmetal, and that's what makes up an ionic bond. So for example, a sodium and a chlorine, you have a metal and a nonmetal. And so just to refresh your memory, remember that sodium has 1 valence electrons. Those valence electrons are those electrons on the last outer energy level of your atom. Chlorine has 1, 2, 3, 4, 5, 6, 7. And also remember that ionic bonds transfer electrons. So that means in that empty space, that electron will go to that empty space, and that gives you your NaCl, and that's an ionic bond. Anytime you have a bond, you have 2 electrons. So you have one from one element, the other one from the other element, and that's what causes your bond. If you have 2 bonds, that means you have 4 electrons. If you have a triple bond, that means you have 2, 4, 6 electrons. So the more bonds you have, the stronger your bond is going to be. So think of it as like a pencil. If you put 1 pencil and you break it, or if you put 3 pencils together and then you try to snap them and break it, it's going to take a lot more energy to break the 3 pencils together. Okay, so think of it that way. All right, so now for covalent bonds, remember it's a nonmetal with a nonmetal. And that's what we're going to be doing this week. We're going to be working with these. And I'm going to show you how to name those. But just to refresh your memory, the ionic bonds transfer electrons. The covalent bonds share electrons. Okay, so if you have something like, let's do water. So hydrogen has 1 valence electron. Oxygen has 1, 2, 3, 4, 5, 6 valence electrons. These 2 electrons are going to share. So now hydrogen is complete, but oxygen is not. So you need another hydrogen to try to do that octet rule that we were talking about a couple of weeks ago. So here they share electrons. This is a covalent bond. Now remember with metallic bonds, which we're really not going to name those, but metallic bonds, they have an electron cloud. Okay, so they have a sea of electrons. So the covalent bonds share electrons, the ionic bonds transfer, and the metallic bonds have an electron cloud or an electron sea. Now, the covalent bonds do not go with your oxidation numbers like the ionic bonds. So ionic bonds, if you had a +2, remember that oxidation number, if it's a positive, it's a cation. Now, those cations, they lose those electrons, okay? But if you have a negative charge, like oxygen that has a -2, it's an anion, okay? And these are going to gain those electrons, okay? And this goes more with ionic bonds. But you need to know the difference between a cation and an anion. A cation is a positive charged oxidation number, and an anion is a negative charged oxidation number. Okay, now also, don't forget your polar and your non-polar. A polar bond is one that is unequal. You have an unequal pool. Okay, just to refresh our memories. A non-polar bond is an equal pool of that electron negativity. So for example, if you, let's go back to that sodium chloride. So chlorine actually has a larger electron negativity, so the molecule or the compound is going to be pulling in that direction. Okay, so chlorine has a stronger pull than sodium, so it's going to be dragging sodium, especially after it transferred its electron. So this would be a polar bond because it's unequal. Okay, however, if you have something like carbon dioxide, carbon, and then you have oxygen, and then you have another oxygen. Oxygen and oxygen are going to have the same pull on that carbon. So even if carbon is stronger or weaker than oxygen, you're going to have the same force going in opposite directions. So that's an equal pull. Therefore, that's going to be a non-polar bond. Okay. All right, now I know this is just a little bit of a review of everything. That assignment that you have is to kind of make sure that we're all on the same page and everybody's okay. So if you have any questions, I want you to stop the video right now and ask me in Zoom. If you have no questions, then go ahead and start on the assignment, okay? Thank you.